Welcome to Think Global Education Services. In this video, we are going to learn about pH titration curves. pH titration curves are used to determine the equivalence point or the stoichiometric point in an acid-base neutralization reactions. It is a plot of pH of a solution along y-axis and the volume of base added during the neutralization reaction along x-axis. The neutralization reaction between the acids and bases are investigated quantitatively using titration methods in which an indicator or a pH meter is used to detect the exact volume needed to reach the equivalence point. Rather than using the indicators to observe the accurate color change, the easiest way to follow the reaction is to record the pH using the pH meter. A big jump occurs in pH at equivalence point, and this point is known as the point of inflection. The equivalence point is determined as being halfway at this jump. By plotting the values in a pH curve, one can determine the equivalence point for an acid-base neutralization reaction. We shall now study an example for a weak acid and a strong base pH titration curve. Here in this example, we have considered the weak acid, which is an acetic acid, and a strong base, sodium hydroxide. This is a graph of pH along y-axis and the volume of the base added in a reaction along x-axis. Over here we can find that a curve which is slowly increasing and a steady point straight line which is parallel to the y-axis, and after the volume of pH the volume of NaOH increases, the curve attains a steady state. This is a curve for the weak acid and a strong base neutralization reaction. Over here, the first point indicates that initially the pH was high in the reaction chamber, and as we start adding the acid from the burette, the pH stays relatively constant until the equivalence, which is labeled as a buffer region, which is reached. Suddenly, at the equivalence point, we can observe a jump in the pH at equivalence point from about 7 to 11 pH range. Once equivalence point is reached, the curve flattens out at a higher value, that is a pH of a stronger base. This indicates that the pH at equivalence is greater than 7 in case of a weak acid and strong base neutralization reaction. The pH at half equivalence point gives us an easy way to calculate the pKa of a reaction, because at this point the concentration of acid will be equal to the concentration of the salt that has been formed. Therefore, the equilibrium expression becomes Ka of an acid, which will be equal to the concentration of H plus into the concentration of A minus divided by the concentration of Ha, which is the acid. Therefore, the pKa can be easily calculated as pKa to be equal to negative logarithm of Ka. Thus, by means of pH curves, pKa could be easily calculated and one can easily determine the equivalence point of an acid-base titration reactions.